So now, after understanding what is internal energy, now we are in a position to discuss the first law of thermodynamics. Now we know that the internal energy of a system, say suppose this is your internal energy U or simply U. So internal energy of a system changes in two modes. Either a energy is supplied. If a energy is supplied or a energy is taken away, then internal energy changes. And the second way of changing the internal energy is by doing work. So these are the two ways how your internal energy changes. Okay. Now this, let's name some terms. So if this is del U, or U is your internal energy. Internal energy. Now after that we have W, that is work done by system on the surrounding. Work done by system on the surrounding. That is, if the surrounding is doing a work on here, it will be negative work. If the work is being done by the system on the surrounding, it will be positive. No, it depends upon your sign convention. Del U, as we have defined, is your internal energy, and del Q, that is the amount of energy. Del Q is the amount of energy. That is amount of energy, or if you're talking in terms of thermodynamics, heat supplied to the surrounding. So these are some of the terms that we have come across. Now what does first law of thermodynamics tells us? First law of thermodynamics tells us that if a heat is supplied, then that amount of heat or that amount of energy is used up in either increasing the internal energy or doing amount of work. So this is what it is being said. That is, if an amount of heat, say suppose this is a system, and an amount of heat energy you are transferring this, so either there will be a change in internal energy, or this system will do some work W, or both, or whether there will be a slight change in internal energy and a slight work will be done. So this is what we know as the first law of thermodynamics. First law of thermodynamics. So for a given equation, del Q is actually equal to del U plus del W. Now this can be modified into total internal energy of the system is equal to del Q, amount of heat supplied minus amount of work done. So the amount of heat that is being supplied subtracted by the amount of work that is being done will give you the internal energy. Also, you can understand this in a very different way also. Say suppose the system may go from an initial state to a final state in a number of ways. Say suppose this system has a pressure of P1 and has a volume of V1. Now this can be converted into a pressure P2 and a volume V2. Say suppose this is a object in a container, it has some volume V1 and it is experiencing some pressure P1. Now there may be a change in V2 with respect to P2. So these are the changes that can take place. Now these changes will take place when you do a amount of work, that is, a surrounding is doing work in the system. So these are the changes that can take place. Now another important thing is that, say suppose if you are supplying heat or if you are supplying energy. Now you find out that there is no change in internal energy. So change in internal energy, that is del U. What is del U? U is internal energy, but del U is change in internal energy. So the change in internal energy, if there is no change in internal energy, say this is 0, then what we can understand is that all the amount of energy that has been supplied is directly equal to the work done. So this is what we can understand from this particular equation. Similarly, if you look at this equation, change in internal energy, that is the amount of change that will happen in the internal energy, is equal to amount of heat that has been received minus the work has been done. So whatever remains will give an increase in internal energy. Now say suppose there is no change in internal energy, therefore the total amount of energy that has been supplied is all used up in doing this work. So by first law, this is what we can understand. Now we already have discussed what is specific heat. Now this is another concept that we will require in order to understand and do calculations from thermodynamics. So let's have a quick recap. Specific heat was change in the amount of heat, that is the heat applied with respect to time t. That is how much heat should it be applied with respect to time, that is, sorry, it's not time, pardon me, with respect to temperature. This is temperature. So the amount of heat that has been applied, this is the amount of energy that has been applied with respect to the change in temperature will give you your specific heat. So this is one of the concepts, and further if you look at our previous videos you will see that we had specific heat for a substance, that is S by M, for say suppose 1 kilo. So M is 1 kilo. For that particular substance is given by S by M, which is equal to 1 by M into amount of heat given upon the change in temperature. And therefore molar specific heat C was given to you as S upon mole, that is number of moles. So this is all the things has been done